Let us discuss this example. This example is asked in IIT JAM examination in year of 2018 and in section C. So no options are provided here. See, what is the given part? So they have simply given an integral and we have to find its value. So there is double integration. If you try for solve it directly, it will be very difficult. Okay. So what will I do? I am going to change the order of integration and we will solve it. So easily we can have an answer of it. Okay. So to change the order of integration, we need to understand the given region first. So let us write. So x is here, so that's why we can say this is limits of y, and obviously these are limits of x. So therefore I will write given region is bounded by what we have. X is equal to 0, we have x is equal to 1, y is equal to x, and y is equal to 1. So you know that x is equal to 0, this is equation of what? Y-axis. X is equal to 0, right? X is equal to 1, this is a line parallel to y-axis. So x is equal to 1 is a line which is parallel to y-axis. It will be like this. Next, y is equal to x. This is a line passes through origin, passes through 0, 0. It's a very standard line, as you know. So it will be line like this, y is equal to x. See, y is equal to x. This line we have. Next, y is equal to 1. This is a line parallel to x-axis. Parallel to x-axis. So y is equal to 1. So line we will have like this. Y is equal to 1. You can easily find this point is 1 comma 1. Okay, this point is 1 comma 1. So see, we have got two regions. So maybe you will get confused which region we have to consider, or what is the region of integration. See, given integral, inner integral is with respect to y. That means given strip is parallel to y-axis like this. So that strip is bounded below by this line. Getting strip is bounded below by y is equal to x. That means our region lies above this line y is equal to x. So this is a given region of integration. Okay, so this is a given region of integration. So we have to change the order of integration. So that's why we supposed to consider a strip parallel to x-axis. So I mention here, consider a strip parallel to x-axis. Parallel to x-axis. So I will draw a strip here. So which is parallel to x-axis. Okay. So after that, I will find limits of then x, y. Okay. So now our strip is parallel to x-axis. So that's why we will write limits of x first, then limits of y. What is our funda? Bounded below, bounded above, and bottom to top. In this way, we have to find the limits. The strip is bounded below by this line, whose equation is x is equal to 0. And strip is bounded above by that line, cross line, whose equation is y is equal to x. That means x is equal to y. After that, we should write the limits of y. So see, after that we will move a strip like this from bottom to top. So it will move up to this point, getting where the value of y is 0. So that's why 0, and it will move like this, and it will go up to y is equal to 1. So limits of y are 0 to 1. So we have got a limits. So but there is no more space to write. Make a screenshot of it, then we will go further. Let us use these new limits to solve the this integral. Okay, so see, our strip is parallel to x-axis now, so that's why we write dx first. After that I will write dy. What are the limits of x? 0 to y. What are the limits of y? 0 to 1. Okay, so let me remove these limits now. Our inner integration is with respect to x now, so that's why functions of y are constant. Okay, so I will take it outside the integral. So integration 0 to 1, y raised to 4 will come outside. What is this integration with respect to x? Its integration will be e raised to xy square. Whatever the multiple of x we write in denominator, multiple of x is y square. So y square will be in denominator, 0 to y dy. After that, y square will get cancelled. So the integration 0 to 1 we will have y square. Here I am putting upper limit first. So e raised to y into y square, y cube minus, I am putting 0, e raised to 0 is 1 dy. After that, we cannot solve this integration directly. Again, there is a need of substitution. So let us put, I am going to put here, putting y cube is equal to t. What I am going to do, I am going to put y cube is equal to t. So you know that when we put anything, first of all, we have to find its derivative, and after that, we have to change the limits. Let us do that. I am going to find its derivative. Its derivative will be 3y square dy, and here derivative of t is 1, so dt we have. So y square and dy we can replace it by, I'm going to shift 3 on that side, so therefore we will have y square dy is equal to dt by 3. Let us talk about limits now for y is equal to 0 and for y is equal to 1. So let us find new limits of t. So if I put y is equal to 0, value of t is 0 obviously, and if I put y is equal to 1, value of t is 1. So therefore, I is equal to new limits 0 to 1, right? E raised to t, this is our t, minus 1, and y square dy is equal to dt by 3, right? So 1 by 3 is constant, will come outside. Integration of e raised to t is e raised to t, integration of 1 is t, 0 to 1, 1 by 3. I am putting upper limit e raised to 1 e minus here 1 minus, if I put 0, e raised to 0 is 1. If I put 0, 0 we will have, right? So what is the final answer? E minus 2 by 3. So this is a required answer. You can make a screenshot of it, then we will stop. Thank you. Bye bye.